In this video, we're going to continue our work with the rules of indices and look at fractional and negative fractional powers. Let's start off with some notation. A to the power of m divided by n can be written now as the nth root of a to the m. We could also write this now as a to the power of m over n is equal to a to the power of 1 over n raised to the power of m. I prefer this particular notation as it seems more intuitive to work with. So let's have a look at this in action, and we'll start off with a nice straightforward example. If I have 25 to the power of 1/2, this is not 12.5. It's not going to just simply be a case of halving the number. We're raising it to the half power. Just to give you a bit of insight, x to the half could be written as the square root of x. So what we're looking for here is the square root. We take the second root as that's in the denominator, and then all we do is raise to the power of the numerator. In this case, nice straightforward because it's 1. So the square root of 25 is going to give me 5, and then we would raise 5 to the power of 1, which is quite clearly 5. If we look now at 8 to the power of 1/3, it's telling me to take the third root. The third root is the cube root. So if I had now x to the 1/3, we could write this now as the cube root of x. So what number multiplied by what number multiplied by what number gives us 8? Well, that's going to give us 2. Then all I need to do again is raise it to the power of 1, which is quite clearly going to give me 2. You might be saying, well, what's the point in not just writing down here 2 and 5 instead of 2 to the 1? The numerator of each of these fractions is simply 1. If it isn't, we need to make a slight alteration, and this is where this notation really helps. So what we're going to look at now is 25 to the power of 3/2. I'm going to write this as 25 to the power of 1/2 raised to the power of 3. We've seen that a to the power of m raised to the power of n is equal to a to the power of m multiplied by n. We can see that 3 times a half is 3/2. We know that the half root, or 25 to the half power, gives me 5. I then need to cube my answer. So once I was putting in here 1, this time I'm putting in 3. 5 to the power of 3 is 125. So if we were evaluating that, that is what we would get. Okay, let's look now at 8, and what we'll do is 8 to the power of, we'll go for 2/3. So I could write this as 8 to the power of 1/3, and we would square the answer. We've already established that 8 to the 1/3, or the cube root of 8, is 2. All we would do then is square our answer, and that would give us 2 squared, which is going to give us 4. It's that straightforward. We look at the fraction, and we take now the root of the denominator. So for example, if this was 4, we would take the 4th root. If it was 5, we'd take the 5th root. Once we found that value, we then raise it to the power of the numerator. This is an 8 divided by 3, or 1/3 of 8. That is incorrect. Okay, let's have a go. So what we've got then is 25 to the half power. If this was an exam question, 1 mark, we could simply write down 5. We've just seen that. 8 to the 1/3 power, again, cube root of 8, we've just seen that, which is going to be 2. 81 to the 1/4 power. This is asking me to find the 4th root of 81. So essentially we're looking for something multiplied by something multiplied by something to give us 81. We know that that is going to be now 3, so we can write down that 81 to the power of 1/4 is going to give us 3. So nice and straightforward. If this was to the power of 3/4, all we would do at this stage is raise 3 to the power of 3. So if I just write this down, 81 to the 3/4 power is going to be now 3. We've just established a quarter power is 3, and then we'd raise that to the numerator, which would give us 27. Okay, let's look at the next one. 16 to the power of 0.25. Well, 0.25 as a fraction is 1/4. So this is asking me now for 16 to the power of 1/4. We want the fourth root of 16 raised to the power of 1. 2 times by 2 times by 2 times by 2 is going to give me 16. So we can say this is 2 to the power of 1, which of course is 2. In an exam, you would simply write 2. Okay, this one, 0.01 to the power of 0.5. You don't have to, but I'm going to write this now as a fraction. This is going to be 1 over, now we've got 100. So 1 over 100, and we want now the square root of this. This is to the power of 0.5, which is a half. So 1 to the half power is just going to give us 1. If we want the half power or the square root of 100, well, that's going to give us 10. At this stage, you could say, well, I'm now going to raise that to the power of 1, which of course is going to give us 1 over 10. Or if we wanted to write it as a decimal, 0.1. So all I've done is written that as a fraction, converted this to a fraction, and used the laws. So for example, now if we had, let's write 0.01 to the power of 1.5. We could write this as 1 over 100 to the power of 3 over 2. So if we look at that, that is going to give me now 1 over 10. I've simply taken the square root exactly as I've done here, but instead of raising it to the first power, we raise it to the third power. So this is going to give me now 1 over 10 times 10 times 10, which should give me 10,000. So that would be the fraction, and of course you could write it as a decimal if you wish. We're not asked to do that, and we will practice these later on. Okay, next one, what we've got is 3, and we'll just find some more space. Let's go ahead and do that. 3 multiplied by 125 to the power of 1/3. This is asking me for the cube root of 125. We've already seen that that's 5, and I simply need to raise that to the power of 1. So this is going to be 3 times by 5, which is going to give us 15. Okay, this one is slightly more challenging, and I'd say a bit of extension. So this is going to be, and you might want to just leave this as a decimal, this is going to be 9/100ths to the power of 1/2. So we're looking for the square root of this. The square root of 10,000. We're looking now for the square root of 10,000, which will be nice and straightforward and simply now give us 100. So square root of 10,000, what multiplied by itself gives 10,000, that is going to be 100. Okay, so let's look at this right here. We've written this now as 9/100ths to the half power. 9 to the half power, so we need the square root or the second root of 9, which is 3. 100 now to the half power is going to give us 10. We're going to multiply that by 100, and of course this will cancel down, and that is going to give us now a total of 30. If you wanted to check this in a calculator, you could do. Let's go ahead and do that. So we got 0.09 to the power of 0.5, or you could of course put the half in, multiplied now by the square root of 10,000. So that's 100, there we go, and we get 30. So using a calculator is perfectly fine to check your answers, but again, that would be quite a higher end exam question in this particular topic. Okay, so what we've got here now is the following. Simplify the following. So this is m to the 4th raised now to the power of 1/2. So that's just going to give us m to the 4 over 2, which is going to give us now m squared. So we've got a half power here, but again, we're just using the law now of a to the power of m raised to the power of n is equal to a to the power of m multiplied by n. Okay, this one, we've got now 8m cubed raised to the power of 1 over 3, sorry. So what we need to consider now is that that is 8 to the power of 1. So what we'll have then is 8 to the 1/3 multiplied by m cubed to the power of 1/3. If we just think about 8 to the 1/3 power, we're taking the cube root, that's going to give me 2. If we do 3 times a third, that's going to give me 1. So my simplified answer is going to be now 2m. Here, the 3 is on the outside, so we're going to leave that alone. And then what we're going to have is 16 to the power of 1/2. This isn't asking me to half 16, it's asking me to raise it to the power of now 1/2. And then we're going to have m to the power of minus 1/2. So m to the power of minus 1/2. 16 to the half power, the square root, is going to give me 4. So what we're going to have then is 3 lots of 4. Now this can be written in many different ways. We can of course leave it as m to the negative 1/2, and that would give us now 12 m to the negative 1/2. We could write this as 12 over m to the half, or 12 over root m. So if you had a more challenging question, it might ask you now to go ahead and write this in this particular form. Remember that the half power is going to be the equivalent of the square root when we're looking at those powers. Okay, this one, let's just go through this fairly quickly. So what we're going to have then is 625 to the power of 1/4. I want the fourth root. The fourth root of 625 is 5. Then we can have m squared raised to the power of 1/2, which is going to give me m to the 1/2. This is going to give me now n to the power of 3 over 4. We're going to multiply this now by 81 to the 0.5. That's asking me for the square root of 81. The square root of 81 is 9. Then I'm going to have m to the half, so I'm going to write that as a fraction. And we're going to have n to the power of 1/2 also. 5 times by 9 is 45. Using our rules of indices, a to the m, let's write this here, a to the m multiplied by a to the n is equal to a to the m plus n. All we're going to do is add a half and half, so that'll give us 1m, and then we're going to have 3/4 and a half, so that's going to give us n to the power of 5 over 4, or if you like, 1.25. So that's an extension question. We're simply now using the laws that we know, taking the quarter and half power and then tidying up. Okay, let's look at some more. We're asked to evaluate the following. So again, we're looking for a numeric answer or numerical answer to these. So what I'm going to do is write that this is going to be 8 to the 1/3 squared. 8 to the 1/3 is going to give me 2. 2 squared is going to give me 4. We are taking the third root of 8, whatever our answer is, we're raising it to the power of 2 or squaring it. So on the next one, we've got 16 to the 1/2 raised to the power of 3. The half power of 16 is the square root, which is 4. 4 to the power of 3, which is going to give me 64. I'm simply evaluating. 27 now to the 1/3 raised to the power of 4. The cube root of 27 is going to give me 3. A common error is students writing 9. This is going to give me 3. 3 to the power of 4 is going to give 81. 81 to the 0.75. This is 81 to the 3 over 4. We could write this now as 81 to the 1 over 4, and we'll cube that. We've seen that the fourth root of 81 is going to give us 3. We would raise 3 to the power of 3, which is 27. 32 to the 0.6. If we consider 0.6, and let's just write it here, 0.6 is going to be equal now to 3/5. It's 6/10 or 3/5. So this is 32 to the 3 over 5. We can write this now as 32 to the 1 over 5. So we need the fifth root and cubed. What times what times what times what? I think I need another times what. The fifth root of 32 is going to be 2. 2 cubed is going to give me 8. Okay, with this one, all we need to do is simply do 4 to the 3 over 2 over now 81 to the 3 over 2. If you're unsure with that, all we're going to do is take the square root of these and then simply cube it. So what I'm going to say then is 4 over 81 to the power of 1/2, and what we're going to do with this now is go ahead and cube it. So if I do the half power of 4, That's the square root, which is 2. The half power of 81, which is 9. We're going to cube this, so that's going to give me now 729. Take a guess at that. Let's just check that. I'm pretty confident 9 to the power 3 should be 729. So there we go. So nice and straightforward. We take the square root and cube, even if it is a fraction like so. A fraction with a fractional power. Okay, let's look at some others. Right, we got 3 to the negative 2 multiplied by 27 to the 1/3, all squared. I'm just going to rewrite this. Now, we've got a couple of choices here. I could write this as 1/3 squared, which is 1/9, which we've seen in a previous video, multiplied now by the cube root of 27. 27 to the 1/3 is going to be 3, and we're going to square that. So that's going to be 3/9, which is going to be 1/3. We need to square that, and that will be 1/9. An alternative here was to now go ahead and just manipulate this to write this as a power of 3. So what we could have done here is 3 to the minus 2, and then multiplied by 3 to the power of 3 raised to the power of 1/3. What I've done here is written now 27 as a power of 3, which is 3 cubed. So what we end up with now is 3 to the power of minus 2 multiplied now by 3 using the rules of indices to the power of 1. Multiplying, we go ahead and add the powers, so that becomes now 3 to the minus 1, which is 1/3, and of course we squared it. So there we go. That's a couple of different approaches with that. Perfectly fine either way round. Okay, let's now have a look at the next one. 1 9/16 to the power of 1.5. The first thing I'm going to do is convert that mixed number into an improper or top-heavy fraction. 16 times 1 is 16, plus 9 is 25. So what we have is 25 over 16 to the power of 1.5. 1.5 as a fraction is 3/2. So I'm going to do 25 over 16 to the power of 1/2, the square root, and then I'm going to go ahead and cube it. So this is going to give me now the square root of 25 is 5, the square root of 16 is 4, we need to cube our answer, 5 to the power of 3 is 125, 4 to the power of 3 is 64, and that is our final answer. Don't leave the brackets at the end, I've put them on, but you certainly don't need those. So all you're doing is simply manipulating those. Okay, let's have a look at this one just here. We're asked to simplify the following. We've got 8m cubed to the power of 4/3. So what we're going to have then is 8 to the power of 4/3 multiplied now by m cubed to the power of 4/3. So if we consider this, this is 8 to the power of 1/3 to the power of 4. If we look at these, when we multiply, we're going to have 3 times by 4/3, which is simply going to give us 4. The value here will cancel with the denominator. The cube root of 8 is 2, 2 to the power of 4, so let's write this here, 2 to the power of 4, times by m to the power of 4, 2 to the power of 4 is 16, and that will be 16m to the 4th. So we simplify that. Let's look at the next one. 9 to the power of 3/2 can be written as 9 to the 1/2 cubed times by now m to the power of 4 to the power of -3, which is m to the -12. We've got now the square root of 9, the second root of 9, which is 3. We raise that to the power of 3 and multiply it by m to the -12. So 3 to the power of 3 is going to give me 27, and then we'd have m to the negative or -12. So 27 over m to the 12 is another way that this could be written. Okay, let's move on and look at some others. We're asked to evaluate the following. What we've got here is 25 to the negative 1/2. So what we could write then is, instead of 25 to the negative 1/2, we could write this now as 1 over 25 to the power of positive 1/2. We saw this with the negative value in the previous video. If you haven't seen that, do check it out, as I'll assume that you know this. So what we've got then is 1 over 25 to the half. We know that this value gave us 5, so it would be 1 over 5. 8 to the negative 4 over 3 is going to give us 1 over 8 to the positive 4 over 3. We could write this now as 1 over 8 to the power of 1/3 raised to the power of 4. We've already seen that 8 to the 1/3, the cube root, or the third root of 8, is 2. So that would be 2 to the power of 4, and that would give us 1 over 16. Here now we've got 3 multiplied by 1 over 16 to the positive 3/4. This is going to give us 3 multiplied by 1 over 16 to the 1/4 raised to the power of 3. That's going to give us 3 multiplied by 1 over 2 cubed. 2 cubed is going to give us 8, so that will give us 3 over 8. Okay, 9 over 25 to the negative 3 over 2. So what I'm going to do is write this, and we saw in the last video that if we have a negative power, what we can do is invert the fraction and write it as a positive power. If you haven't seen that video or not comfortable with that, please do go and watch it. So all I'm going to write now is that this is going to be 3 over 2. Okay, so what we're going to have is the following. We're going to have 25 over 9 to the power of 1/2, which we're then going to cube. You can, of course, use square brackets if you want to make that look a little neater. So what we'll have is the half power of 25, which is going to be 5, the square root. The square root of 9 is 3, and now we need to cube. That's going to give me 5 to the power 3, which is 125, and 3 to the power 3, which is 27. So if you wanted to look at this on a calculator, hopefully it will default to what we want, and we can type this in now as 9/25. So 9 over 25 to the power of negative 1.5, which is the same as 3 over 2, and hopefully it will give us that value, 125 over 27. Okay, let's look at this one. We've got 0.16 to the negative 1/2. So we could write this as 16 over 100. 0.16 could be written like so, to the negative 1/2. We could simplify this if we wanted. We could divide now the numerator and the denominator by 4. You don't have to, but you could do. So that's going to give me that. We can invert the fraction and write it as 25 over 4 to the positive half power, as we got the negative half power. We take the square root of 25, which is going to give me 5, and the square root of 4, which is going to give me 2. So our final answer is going to be 5 over 2, and of course we can check this. So 0.16, you wouldn't necessarily have a calculator in the exam, but if you're doing this as a building exercise, we can see now that that gives us exactly what we want. So these now are negative fractional indices. Okay, let's go ahead and look at some others. So we've done these ones. Simplify the following. Okay, so we've got now 4m to the negative 1 all to the negative half times by 5 squared. So this will be 4 to the negative 1/2 multiplied now by m to the positive 1/2. So if we do negative 1 multiplied by negative half, that's going to give me 1/2 multiplied now by 5 to the power of 2, which is 25. 4 to the negative 1/2 is 1 over 4 to the positive 1/2 times by m to the half times by 25. So this is going to be 1 over 2 multiplied by m to the half multiplied by 25. So I'm going to write it as 25. All we're looking for is the square root of 4. 25 over 2 m to the half, or if you wish, 25 over 2 root m, remembering that m to the half is the same as root m. So that's the first one done. This one looks an complete mess. Let's just work through it. So what I'm going to do, we've got 9m to the 0.5 n squared over 25 to the negative 3 over 2. So I'm going to rewrite it as an inverted fraction with a positive power. So we've got 9, then m to the 1/2 n squared, and we'll raise this now to the positive 3 over 2. So what we're going to have then is the square root, and in fact I'll do this step by step. So what we're going to have then is 25 over now 9m squared, m to the half n squared to the 1/2, and I'll bring out a square bracket to make it look a bit tidier, and we're going to cube our answer. So that is what we're going to have. So what we're going to have now in here, and I'll do this in one hit, we're going to have something here cubed. 25 to the half, we're looking for the square root of 25, or the second root. Well, that's going to give me 5. Okay, what we're going to have here is 9 to the half. 9 to the half is going to be 3. We are raising to a power, so we need to multiply. So that will be m to the power of 1/4. Half times by half is 1/4. And then we'll have n squared times by a half, n, and then we got squared. So the squared times by a half is just going to give us 1. Okay, so if we just tidy this up, 5 to the power 3, 125. 3 to the power of 3, 27. This is now going to give me m to the power of 3/4, just multiplying 3 1/4, n cubed. Job done, and that now is our final answer. Right, okay, let's look at this one right here. Now, a few different ways of doing this. I can see that I've got m's here, so I'm not going to evaluate them necessarily each time. What I'm going to have then is 2 to the minus 3. So if I raise this now, 2 to the minus 3 is 1 over 2 cubed. And then I'm going to have m to the negative 3. All that is negative 3 times by 1. I'm now going to multiply this by 32m squared to the power of now 2.5. So 32, 2.5 is 5. What's that going to give me? 2.5 is going to be 5 over, let's just write that in, 5 over 2. Now this looks like it's going to be quite messy. So let's now look at this, and then we're going to have m to the power of 5. 2 times 2.5 is 5. Just looking at this, I'm going to write this as a power of 2. I might have to leave my answer as a power of 2. So let's just look at this. We've got now, in fact, I'm going to write that back as 2 to the minus 3, m to the minus 3, times by, now this is going to give me 2 to the power of 5, raised to the power now of 5 over 2, and then m to the power of 5. I think I'm going to have to leave this as a power of 2. I don't think it's going to look pretty. So we've got 2 to the negative 3, m to the negative 3, multiplied by 2 to the power of 25 over 2, m to the power of 5. So we're adding here now when we're multiplying the bases. So this is going to be 2 to the power. And what's this going to be? This is going to be, that's going to give me 6 over 2. So what's that? 19 over 2. And then we're going to have m and then negative 3 and 5 multiplying. So we add that. That is my simplified answer. It's not going to be pretty, but that's what we would do. We would leave it like so. As I say, I don't think that's going to look any better than a power of 2 and then a power of m. So there we go. That's some work with negative and fractional and negative fractional indices. All we do if we have a fractional index is take the root of the denominator and raise to the power of the numerator. If it's negative, we invert it and carry out the same operation.